Welcome back everyone for my Math Online today. I'm happy today to show you another video online about sketching of rational function. Before I get into the lesson, please let me remind you about visiting my website, mymathteaching.ca, where you can find my portfolio teaching, including my teaching reports, um, my resume, and on my teaching journey experience there for you to see. Um, also, um, if you know any student who has been struggling in mathematics and would like to understand more about pre-calculus math 12 or introduction to calculus, you can recommend my online teaching videos from my school, math courses online.teachable.com. And thank you for your support. Um, I also want to um, talk a little bit about how important mathematics education for future education. I have watched the video from YouTube about the cryptocurrency. It has been invented by the person named Satoshi Nakamoto, and he mentioned about he used mathematics and advanced technology to um, invent about the blockchain information system. And that might be our currency in the future. So you can see that the digital world evolution has changed on the aspect of our life. And there never been such a good time right now to invest in mathematics education for our young generation. Um, I believe that mathematics education is so important because even though math and technology are different branches, and you didn't see how well they connected each other. But as I mentioned, Satoshi Nakamoto has used mathematics and technology to develop the program called blockchain information that will totally change our financial future um, and our lives. So um, the good thing about math is it's never have been out of date. What lesson we are learning in math thousand years ago until now never been changed. The core of foundation of mathematics never been changed. And without mathematics, we don't have advanced technology. So anyway, now the time for me to get back to the lesson. So on the board, I have a shape of the new rational shape and the little small image here to show the basic shape of our rational function. Now in this lesson, I will not analyze too much about the characteristic of the rational function and how we do it because I have shown you in my previous video. And that's why sometimes if you watch the lesson from my math courses online, you see the whole of sequence connected together. If you jump in the middle, you might not know what I'm talking about because I'm not teaching the whole one videotape, but I am teaching the whole sequence of it. So there will be some parts I have to move a little bit faster. So let's see what we learned today. So today we will learn how to sketch the function for number one here. And number 2 here, we will write the following equation in the form of transformation based on the sketching already shown to us. So before I get into the sketching of this function, let me remind you about the basic shape of the rational function. So this is the basic shape. And on the bar, you can see that I have a vertical y-axis, but dotted, and horizontal axis, but dotted, because they represent the asymptote. And the asymptotes mean the line where the function cannot cross through or touching it. It just get close but never touch it. And that's why we call it asymptote. And why the rational function have asymptote, we have learned from previous lesson about the analysis of rational function. So if you forget, you can rewind the YouTube and then watching back my previous video. Connecting with this video, you will understand it. So we have an asymptote here, an asymptote here as a y-axis and the x-axis for the basic function. Now, let me remind you a little bit about the transformation, which is we also learned from our previous video. So the basic function is y equal 1 over x. But the transformation here will be equal y equal a divided by x minus h plus k, where a is the vertical stretch factor, h is the translation shift the function left or right, and k here is the unit shift the function up or down. Now, based on that understanding, and we apply to here, you can see that the vertical asymptote from the basic one as a y-axis now no longer be here, but it moved to the left by 2 units. 1 minus 2. So this asymptote instead here moved to the left 2 units here. The horizontal asymptote for the basic function instead of an axis, which is this line, now move it down by 1, 2, 3 units. And therefore, we can make a statement of the horizontal asymptote here is the line y equal minus 3. Because this is minus 1, and this is minus 2, and this is minus 3. So when we sketch the rational function, usually the curve will the curve will shape along the asymptote, along the vertical asymptote. And so, for example, here, the shape is never touched the asymptote, but it crossed the x-axis at this point, go through the y-axis at this point, and shape along with the horizontal asymptote. So that is the basic shape of any rational function, whether it's shift left or right or up or down. And you can see this very much the same like the shape of the basic, except that we shape along with the vertical asymptote and horizontal asymptote. So that is the way we sketch the rational function. And if you know how to sketch it by hand, it even looks better than you punch in a number and plot it on the graphing calculator. And I said that I believe technology to help mathematics is a tool for us to learn math, but cannot be another subject to replace math. So even though I don't deny the importance of advanced technology, but I my teaching philosophy is based on the core concept, the core information of the foundation of math. Set multiplication or division table or the pi number never been changed. And sometimes the traditional learning require us to understand the basic core of math should be important as well as our um, invention of new ideas. So anyway, um, so this is the shape of the basic rational function as we shape along the vertical asymptote and the horizontal asymptote. So based on the shape, let's start sketching our rational function here. So what do we need to know when we sketch rational function? First, we have to know vertical asymptote. Second, we have to know horizontal asymptote, just like this. And if we know some y-intercept or x-intercept or another point on the graph, it will make us to be able to sketch a very much accurate image. So now, based on the transformation, we know that our factor A in here equals 7. It means we have a vertical straight factor of 7. And the reason, because our original is 1, now we times with 7 on top, right? So that is the vertical straight factor of the y function, so of 7. Now, minus 4. Yesterday, I have mentioned to you this point is very important because this point will show us this is our horizontal asymptote. So our horizontal asymptote here in this form already known by this number, which is y equal minus 4. So based on this, minus 4, just the same like letter K here, we know that the transformation of our basic rational functions have been shipped down by 4 units because this is negative 4. So shipped down by 4 units. So therefore, I mark our new horizontal asymptote here as the dotted line here at minus 4. And this is our new horizontal asymptote for our new function here. Now, our vertical asymptote will be based on the denominator because this function will not exist if our denominator down here equals 0. And what value of x make the denominator here 0? So the x here have to be equal to make the denominator is 0 because 2 minus 2 is 0. And therefore, this is the vertical asymptote where the function cannot cross that line. So our vertical asymptote at x equal 2 based on this denominator. And this is 1 and 2. So now we can sketch the vertical asymptote for our function here. So now what else we have to figure out? If we can figure out the y-axis, the y-intercept or the x-intercept, then we will be able to sketch a better image, more accurate. So let's find out the y-intercept. Now to find the y-intercept, and yesterday I mentioned in our previous lesson, we will set the x equals 0. So we set the x equals 0 to find y-intercept. So if our x equals 0, our y will be equal based on this function will be 7 minus 0 minus 2 minus 4, which is minus 702, which is minus 3.5, and minus 4, so equal minus 7.5. So let's put in the point form. 0 is x and y is minus 7.5. So this is our y-intercept. Now let's find out what is our x-intercept. Our x-intercept will be able to found to be found using the setting the y equals 0 to find x, right? To find y-intercept, we set x equals 0. To find x-intercept, we set y equals 0. So this equation will have a form 0 for this replace for y equals 7 over x minus 2 minus 4. Now to solve this equation, I will move the 4 over. At this level of Math 12, I believe that everyone will know how to solve the equation already. So I will go through it quickly so that we can have time to learn other important things in this lesson. The solving equation, you might solve in different way as I solved, but the answer should be the same. So minus 4, I will move it over, negative become positive, equals 7 over x minus 2. Now, instead multiply both sides, I'm going to kick this bracket up here and I tie the number 4 with this. So I got 4x minus 8 equals 7. Now move the a over, adding into the 7, I will have 4x equals 15. Divide both sides by 4, I have x equals 15 over 4, which is 3.75. So now I know my x-intercept will be equal 3.75 and 0 for y. That is my x-intercept. So now we know x-intercept, we know y-intercept, we know vertical asymptote, we know horizontal asymptote, and our horizontal asymptote is y equal minus 4. We're going to be able to get the function. Let's plot the y-intercept. Y-intercept 0 minus 7.5. So this is minus 3 minus 4 minus 5 minus 6. 4, 5, 6, 7. So 7.5 is this point here. And that is our y-intercept. And our x-intercept is 3.75. So 1, 2, 3. 3.75 about here. And 0. So this is x-intercept and this is y. Now, at this point, we'll be able to sketch the rational function, but let me find out another point on the graph. So maybe we do more accurate, right? And it's easy to pick any point. Let's say if I pick the point minus 3 here, right? So I know I pick a point, right? I pick a point, x equal minus 3. I'm going to solve for y, right? To find out the coordinate y. And I'm going to use this equation to solve for it. So I have equation y equals 7. Our x is minus 3. I'm going to substitute this value with minus 3 and minus 2 and minus 4. So what do I get? I got 7 over minus 8, right? Our x is minus 3, yeah, minus 3 and minus 2, sorry, minus 2. So that will be 7 minus 5 minus 4. Now 7 minus 5, what is the point is that? Let's see, 1.4. So 7 minus 5 is minus 1.4, adding with minus 4, will be equal minus 5.4. So our point will be x is minus 3 and y is minus 5.4. So this is minus 4, minus 5, 5.4 is about here. So our point is right here. So let me erase this mess. So now we know the point we pick is right here, right? X is -3 and Y is -5.4, sorry, -5.4. X is -3 and Y is -5.4, this point. And what else do we need to know? So we have the Y-intercept, we have the X-intercept, and we have the horizontal asymptote. So all what we do, we will sketch the function across this point and go through here and shape along with the horizontal asymptote. On the side, we will sketch something look like this. We'll across this point, also across this Y-intercept here, and get shape along with the vertical asymptote. So this is our new sketches based on this function. Now, I hope that you will find, oh, it's such easy to sketch it using hand sketching rather than punching the number in the wrapping calculator. Okay, so now let's progress to the next question. So our next question, we will talk about how to write the following equation in this form using this graph. So let's see how we can figure it out. Okay, so let me see. I think that I have to erase this so that we can continue with the question 2. So in the question 2, we are given the graph and we have to write in this form. So we have to figure out the equation in this form. Now, to write an equation, you will fill in any number you know and solve for the unknown number. That usually is starting way of doing it, right? So in this here, you will substitute whatever you know. This is the Y value. So let me pick a point on this graph so that we can substitute in this equation and figure out the unknown information. Now, if we pick the point of Y-intercept, that's okay, but that is pencil point, right? It's the Y-intercept. And if we pick the point X-intercept, that's also okay, but that is pencil point. So I would rather pick a point is not a pencil point. And we have a point right here. Let's check this point. This point right here have the X-intercept as 2 and the Y-intercept at -2. So let's pick this point right here. So this is X and this is Y. So now I'm going to substitute any information we know in this equation and solve for it, right? So -2, we substitute here for Y because that's the Y coordinate, so -2 equal. Now, A, we don't know. The factor of vertical stretch, we don't know. X is 2, right? Based on this point. So I'm substituting the X by 2 minus H. Now, H here indicate the vertical asymptote, right? Indicate the vertical asymptote shift to the left or shift to the right. So here, let's look at this asymptote here. So we know that instead of original from here, now it's shift to the left 2 unit, -1, -2. So we can substitute this by -2. and put in bracket, right? Minus the k here is a vertical, no, horizontal, up or down. So our horizontal here is supposed to be original here, but now shift down by -3. So I'm going to substitute this by -3. And the sign here already minus for us. So yeah, so actually the original should be plus, but this is our -3 because we shift down. So now the only number unknown we have to figure out is letter A. Everything else is already there for us. So let's solve this equation. So I'm going to move this -3 over to the left. And therefore, I will make -2 plus 3 equal the A is just A. Down here will be minus. Minus become plus, right? Minus times minus plus. So that will be 4. So now this number will become 1 equal A over 4. Now kick this number up. I will have 4 equal A. So now we know we have a vertical stretch by a factor of 4. So let's write down this equation. The equation for rational function is just y is y. A is 4, we figured out here. And the x is just the x, right? Because in any function, you have to have a y and the x represent, right? Minus h, we know we shift the vertical asymptote to the left by 2 units. So this will be plus 2. And we shift down by 3 units, so 3. So here you go. This is the answer based on our graph. So because I have analyzed this function yesterday with you a lot about characteristic of it, why it have a horizontal asymptote, what the reason it has a vertical asymptote, and how we shape along with the x-axis or the y-axis asymptote. So now in this lesson today, I will not go through all of that with all the details like that. So that we can have time to sketch it and to figure out the equation. One more thing I want to do in this lesson is the last question here. And why do I do that? Because I have a purpose. So this is the rational function, no doubt, right? So let's do that here. So let me erase this, and we're going to start work on the question 3 right now. So the question 3 gives us the function f of x equal x squared minus x minus 2 over x minus 2. Now assume that you don't have a graphing calculator. We're going to be able to sketch this function. So let's factor this function like yesterday I showed you, right? Factor it out. So we have an f of x, the same function which is factored, right? On the top, we will have 2 brackets. An x will go in here, and this is minus 2. So if I split this, it will be 2 times 1. And when I add these 2 numbers, I should get back to -1 here in the midterm. That's how we factor it, right? So we'll have x minus 2, and then x go in here because x times x will get back to x squared. And 1 number will go in here and should be a plus sign because -2 times 1 will get back to -2. So factor is the fact that we can able to break down the algebra in terms of 2 brackets multiplied together like that. Now we have an x minus 2 down here. So let's look at this. What happened in here? We have x minus 2, we have x minus 2. Now they are multiplied, so it means we can cancel. And remember, if we cancel it, it means we will have a home, right? Once cancel, it means the home will exist in our rational function. And how do we find out the value coordinate of the home? What is the x and y coordinate of the home here? We will base on this, x minus 2, we can set this equal 0 to solve for the x value where the home occurred. The reason why, because if you have a rational function, let's say like this, and then you have a home like this, right? Now at this home, you don't have, the y is, the x and y here actually they're not exist, right? It have a coordinate here to indicate where are they, but actually it's empty circle, so it means that the x and y do not exist. So therefore, to figure out where it is, you just have to say, okay, the y is have to be 0 to find out what is our x. So therefore, you solve for the home, and here you will get x equal 2. And now you want to find the y value when x equal 2. You will substitute back into the new form of function, which is x plus 1 over x minus 2, because actually this gone, right? This gone and this gone. So we'll substitute back in here, and it will be equal x is 2 plus 1 is 3. So now you know the home here will be x is 2 and y is 3. And that's how you find out about the home in here. So how do we going to sketch this function when we know the home? How we sketch? Let's find out. Oh, I forget. What is the home equal? X equal 2 and y equal 3, right? So our home is the point is 2 and 3. So let's get this function. Now, if you look at this function like this, you're not going to know what the shape of this function unless we analyze and we factor and we cancel like that. So what is the shape of this function? Actually, the shape of the function is just the linear, because this and this are already cancelled. And how do we get this linear? So instead of rational function, now it become a linear. So this is the y-intercept of 1. So we mark that. And the slope is 1 over 1. So we go up 1, we go across 1, we go up 1, we go across 1. So this is our linear function. And make sure we know the home as well. The home at 2 for x and at 3 for y. So 1, 2, 3. So our home actually right here. So it means this linear function is a rational function. It turned out the rational function like this will become a linear like this and have a home here at x equal 2 and y equal 3. And so here we make sure that the function does not exist, because this is the empty circle. It's the home. The linear like this, but stop right here and then continue from this point forward. So we have a home as an empty circle right here for this rational function. And this is our rational function. And we cannot deny this is a rational function because it have a variable as the denominator and the polynomial on top as the algebra polynomial expression. So this is a rational function, but it has transformed to a linear function, and it has a home at x equal 2 and y equal 3. So that is my last question in this video. I hope that you enjoy my video today, and we'll see you for the next video. I'm going to have to show you another sketching of rational function in another video for two functions before I end this unit in my math courses online, Pre-Calculus Math 12. So please advertise for introduce my courses online for somebody you know they need help in math. The cost is affordable, accessible, and affordable. If you visit my math courses online.teachable, you will see how beautiful my school website look like. So just take a look, and if you know anyone who need help in Math 12, please recommend this video if you like my video. Now, I believe that it's helpful, right? Because if you learn in the middle of the course, and if you're missing some of the instruction from your teachers or anywhere, you can check with my courses and earn the credits from my courses, earn the certificate from my courses as well, online certificate. Thank you for watching, and bye for now.